time I had available. So. All right, I just looked at your email here. Which one do you want to start on?
Let's start on 6.
All right. Let me look at it for a second.
My teacher drew in the blue line.
Okay, and there's no other information other than they want to know what M and N is?
Yeah.
Okay. M being the measurement of that arc and N being that angle. So if we can find either M or N, we'll have the other one, because the measurement of that arc is going to be twice the measurement of that angle. Why does it say yes, the line? Oh, they're telling you that yes, the line is tangent.
Yeah.
All right. Let's see if we can draw this picture. Tangent line, the one thing we know about it is that it makes a perpendicular line with the radius. So that is perpendicular.
Well, that's the line he drew, though, so that's not technically, like, given.
No, I understand.
Okay.
That's 28 degrees. And that's all of the information we have. Let me study this a moment. Yes, the line is tangent. What does that make this angle right here? No, that's still an important angle to know, I think. Yeah. In other words, we still have this line right here, but what is this angle right there?
62.
Okay. And that's going to solve the rest of the problem. If that's 62, what is the measurement of M?
To 124.
No, this is a central angle of 62.
Oh, so then it's 62.
Correct. Now, what's the measurement of N, which subtends the exact same arc?
62.
No. That's not a central angle.
Oh, shoot. 31.
There you go. In other words, let's talk about the two cases. There's really only two cases they've taught you about. One, you have a central angle that subtends the arc of the same measurement, like that. And the other is if an arc is subtended from an angle that is on the circumference, like that. What is theta? What is that?
20.
Yeah, it's half. In other words, there's only two situations. Well, there's more than two, but the two primary ones they're trying to teach you with this problem is that central angles subtend the same size measurement of the arc, but angles that come from the edge of the circumference, like this one, theta, subtend twice the measurement. And if you ever forget whether it's twice or 1/2, merely draw this picture. And you can see that theta has to be less than 40 degrees, right?
Mm-hmm.
Therefore, if you know that the relationship is either 2 to 1 or 1 to 2, it's not hard to figure out which. And I tell you, in geometry, there are so many relationships that are 1 to 2 or 2 to 1. It's amazing, really, when you think about it. It's almost like the magic of circles. When you have a circle, all your relationships are either 1 to 2 or 2 to 1. So once we've solved for m, then we know what n is. All right, let's look at 7. It's not obvious, but I learned just the other day, and maybe it was in our session, that when you inscribe a quadrilateral inside of a circle, opposite angles are supplementary.
Mm-hmm.
I really didn't know that until just the other day. I did not really, I mean, you can figure it out because the angle that is subtended by M, or the arc rather, is supplementary to the arc that is subtended by Q. In other words, if I look at the arc that is subtended by P, it goes from here to here, right?
Mm-hmm.
And if I look at the arc that is subtended by Q, it goes from there to there. So those two arcs add to 360. And since the angles have to be half the length of the arc, P plus Q must be equal to what?
180.
Yeah, they're supplementary. And 90 plus X must be equal to what?
180.
So what is
Wait.
X? Yeah, that's right.
90.
Yeah. So P plus Q is supplementary. There's some additional information here that I didn't see the first time. And that is, that's 28 degrees. And this is 60 degrees. So first of all, well, like a lot of geometry problems, we have to figure out some things first. What is the arc P?
Can I just wait, hold on.
Mm-hmm.
Can I just do it this way?
Go ahead. Yeah, there may be
So
a good way to do this.
I put, well, 90's at the opposite side, you know? Okay, so then
Right?
I did 20, I drew a line between the P and the Q,
Okay.
and I did,
I like that
28
method.
divided,
I like that method.
yeah.
I
So then
think.
it came out with 106
For which one?
and
For P?
E.
And
Because
then
I got
Q,
76 on the side of the line.
Q would be 74, right?
Wait, what? Yeah, 74.
74. Okay. Now, by drawing that line, you made the problem a little bit easier to analyze, but not really any different. In other words, you figured out that angle P must be 30. Not angle P, but the angle right there must be 30. Right?
Mm-hmm.
Well, how'd you go from there? In other words, so that's
Well, then
30 degrees.
they're two right triangles, so I just did 90 plus.
Hold on. Where are you getting a right triangle? Oh, this is a right triangle. Okay. So that's 60.
Yeah.
But
And then the other one is another right triangle because they're opposite sides.
right, okay.
So then I got
What is
14.
that angle and what is that angle? This angle has to be half of 28, huh?
Yeah.
14, which makes this angle 76, which makes P 106, right?
Mm-hmm.
And Q
And
is 74, and they're supplementary. Okay, I like that way that you did it. There's another way to do it, and I probably would have done it the other way, but there's nothing wrong with the way you did it at all. In fact, that might have been the quickest way to do it. Let's see. What's the next one here? 3?
Mm-hmm. 8.
8, excuse me. Alright, on 8, what's the first thing you notice about 8?
There's parallel lines.
Very good. That's exactly the answer I was looking for. Whenever there's parallel lines, you want to notice them because they're going to be critical to the problem. And they use the double arrow. I will too. And that's 82 degrees. And they want us to calculate R and S, and that's 67. Well, let's start calculating some stuff that we can figure out. What's this angle right there?
67.
Okay. Now, because we have parallel lines, if we had a transversal, we could use the parallel lines. It's going to be difficult to incorporate the fact that we have parallel lines unless we draw a transversal, and we don't have one there. So let's just draw one and see what happens. Now I have a transversal between my parallel lines. It's this angle right here.
Um, 82.
What is this angle right here?
Wait, where?
Let me draw it again.
Oh, I see it.
I'll call it X. What's X? R. Exactly. Right? Based on the parallel lines, X is R. Does that help? Let's see. What is that angle right there?
I don't know.
well, let's call that angle, we'll call that angle x. Well, we know that the sum of the angles of a triangle has to be 180. So
the one next to 7 is 31.
minus 82 minus r, correct? That's what x is?
Mm-hmm.
Okay. What is angle, this one right here, we'll call that y.
31.
Okay. Which makes angle S, I'm not sure, sometimes when you work through a geometry problem, you just kind of have to figure out every angle you can. And then the solution hits you like a ton of bricks. I can't, at this point, I don't really have a feel for where we're going here. So I'm just going to try to figure out everything I can. S is equal to what?
31 plus x plus whatever we want to name the other side.
Well,
Angle.
that's 82, right? And that's 31. So if you look at this triangle right there, S is x, excuse me, it's 180 minus x plus 113. Right? In other words, if I look at this triangle right here, there's three sides to that triangle. There's angle X, there's angle S, and there's this angle of 113 degrees. You with me?
Yeah.
Because if you get lost, we're lost here because I'm not sure where I'm going. So let's see. I could solve both of these for X, and then I would have one equation relating S and R, which wouldn't do me a lot of good.
I know what we can do.
What?
All of the lines are parallel or are congruent.
What lines are current?
Not the core. The one with 82 and R on. Okay, so on the right triangle.
Yeah, that means this is R, right?
They're all congruent because
Yeah,
they're
that's
all
an isosceles triangle. In other words, all radiuses, that radius is equal to that radius, which makes this angle equal to that angle. So I can label that angle R. That angle right there.
And then 180 divides 82.
Well, 180 minus 2R equals 82. So we have, let's write that. 180 minus 2R equals 82. That is an independent equation, and that's going to let me solve for R, and that lets me solve for X, and that lets me solve for S. So that's all I need. Let's work with these three equations. Tell me, starting at the bottom, tell me what R is.
49.
Okay, now let's solve for x. What's x equal? I mean, I may be doing this the long way, but sometimes you just have to do whatever way the path leads you. You know what I'm saying? I didn't know how to solve this problem when I first looked at it. So I just started drawing transversals and solving for unknown variables. But
X is 49.
180 minus 131, yeah, x is 49. We probably
So
could
then that,
have figured that out. Now what is s?
49.
Really? 180
Because
minus...
if it's an isosceles, then it has to be 49.
Oh yes, you're right. So s is 49 and r is 49. And that was the goal of the problem, was to solve for r and s. However, when we look at the picture, that doesn't work. Clearly, r and s are not the same. S looks to be about half the size of r. Well, first of all, r we can figure out all by itself just looking at that triangle, right? R has to be 49. Nothing else that r could be. So we've made a mistake on s. S has to be less than 49, just looking at the picture. And s is the same as x, the way I drew it. So let's examine it a little bit. What's this angle? If we know r is 49 for sure, right? That's an isosceles triangle. R has to be 49 because that's the same as that, and then all three of them have to add to 180. So there's no question about the value for r. But then we did something wrong in our math here. So let's kind of go back to the beginning to figure out what s is. To try to figure out our mistake. Well, notice when I draw that transversal, this r is 49, right? Because of the parallel lines?
They're parallel chords, so doesn't that mean the arcs are the same?
Now hold on a second. What did I do wrong here? I extended this arc all the way down. Now I have a transversal for these two parallel lines, and whatever r is, that angle is. So that angle has to be 49, and now that tells us what x is. Well, x has to be 49. But if x is 49, s has to be 49. What's going on here? Ah! No? Hold on. I'm looking at this thing. R is definitely 49. Can't be anything else. And when I extend that transversal, that's the same as r because of the parallel lines and transversals, which would make x equal to 49 also. Just because, or is it? Let's see. Yeah, x is 180 minus 82 plus 49, which is 131. So x would be 49. But that doesn't even match the picture. What am I doing wrong here?
I don't think we have the right number thing for angle for the top of the
It's not
triangle.
82. It's not 82. Let me redraw this part of the diagram here. All right, let's see. When I extended the transversal, this angle has to be 82. Oh, no, it doesn't. No, that's not 82. For sure, this is 49. But notice that the 82 is this angle, right? No, it's not even that. What is that angle? Well, let's see. If I extend the transversal, if I extend the transversal, then that's 180. This is 180. So this angle's 49 or 59, right? In other words, this angle right here has to be 59 degrees. Because these three add to 180. Because when I extended the transversal, that's a straight line through the diameter. So it's 180 from there to there. And that's what we got when we added 98 and 82. And then this is 180 from there to there. So that's 31. This is 59. And now this angle X that I called is equal to 180 minus 90. Which obviously isn't correct. Hold on, I've drawn so many lines here that I'm confused. Yeah, I can see why. I drew my first transversal. Oh, boy.
I got 38.
For which angle?
For the top of that, or for S. I got 104 as the top of that angle, and then I got, because this arc has to be, or the arc with the center as 82 has to be arc length, or arc of 82 too. So 82, 67. 67 goes to the other side too because they're vertical. And then that's 67. And that's a central angle. So then 320, or 360 minus 216 is 104.
So what'd you get for S?
38.
Well, at least that works. In other words, it's less than R, and it looks right. So if that's 38, that's 38, and that would be 76. So this angle would be 104, which I had written in there somehow. I'm not quite sure how, but yeah. Okay. That's correct. Unfortunately, I have to go. So I'm glad you solved this problem. I got kind of confused halfway through and lost my way, which is not hard with geometry. It's easy, but the fact that you solved it's even better than me solving it. And I'm comfortable with your answer, even though I kind of lost how we did it, but I think you're right. All right, Quade. I will talk to you next time.
Alright, bye-bye.
Okay? All right. Bye-bye.